Okay. Just try to ignore the cattail. We should be fine. This is 2.1. We're going to make a graph of a function via a table of values. So in chapter 3, there's much more detail about making graphs of functions. But for now, the kind of like, if you just don't like have any other tools or have any other sort of great informations or strategies, the kind of default strategy is just make a table of values. You can kind of always do this. Essentially, it is you just pick any x value you want. You sort of pick as many of them as you need to try to see the pattern in the function, and then you sort of graph by just sort of plotting the points and connecting the dots. My suggestion for the table is, hey bud, to at the very least start with a few positive values, a few negative values, and 0 in the middle. And let's kind of do that in order. So what I'm going to start with is positive 2, positive 1, 0, negative 1, negative 2. I'm going to leave just a little bit of space in my table. If I need to put in like a positive 3 here to maybe go a little bit further in that direction, I can. And then the same thing here, a negative 3. If we just don't really get a great pattern, if something's not necessarily centered like right in the middle of the graph, then we might need to sort of shift our points a little bit further to the left or the right. But there's no real reason not to just like start in the middle and then go from there. So let's plug these values in. We're just going to sub them into our function. So the function here is f of x is x squared minus 2x minus 1. Generally speaking, an x squared function is going to give us some sort of parabola, so sort of a the U shape or sort of flipped upside down. We don't have a particularly great sense at this point of what to expect necessarily, but something like that is probably in the works. So I'll just sub these guys in essentially in order. So f of 2, so that's going to be 2 squared minus 2 times 2 minus 1. This is going to be for us, positive 4 minus 4 minus 1. Well, 4 minus 4 is 0, minus 1 is going to leave us here at minus 1. I'll mark these y values, I guess, in green. Okay, so that's a start. Let's do f of positive 1. We shouldn't necessarily expect any kind of correspondence between like positive and or negative x values and like positive or negative output values. We just kind of get what we get. So don't necessarily expect any particular type of point coming out of here, at least not until we can start to see if there's a pattern. So 1 squared minus 2 times 1 minus 1. Okay, well that's 1 minus 2 minus 1. So that's going to be negative 2 in the end. You can kind of start to see that the biggest thing here, really more than anything else, is just kind of keeping track of your positives and negatives. Obviously, if you add when you're supposed to subtract or vice versa, you're sort of all your values are going to get a little bit out of whack. Sometimes that'll happen if you sort of mess up one of the negatives just in one of these substitutions, and you sort of end up with kind of one rogue point that sort of obviously doesn't fit in with the general pattern. That's not the worst thing in the world, because hopefully that's going to be easy enough to pick out. This, of course, would be 0 minus 0 minus 1. So this final is minus 1. So that's interesting. We're sort of negative 1, negative 2, back up, I guess, to negative 1. So we're kind of hovering, zigzagging back and forth. Maybe we're sort of right at the turn there. If we do x is negative 1, negative 1 squared minus 2 times negative 1 minus 1. Negative 1 squared, always with our negatives in the parentheses, If we're subbing a negative into here and we're squaring the x, the negative gets squared, so that's positive 1. Negative 2 times negative 1 is positive 2 minus 1, so then this is going to go up to positive 2. So again, if we're putting in positives or negatives, that doesn't necessarily tell us anything in particular about the type of output values we're going to get. This was exclusively negative values so far for our positive numbers, and now we only flipped to positive outputs once we switched to a negative input. Again, this doesn't necessarily mean anything. Trust your gut. assuming you're not getting something that seems just like totally out of left field. Negative 2, right? Negative 2 squared is 4. Negative 2 times negative 2 is also 4. Minus 1, so this is where we're starting to get a little bit of a jump. 4 and 4 is 8, minus 1 is 7. That might seem a little bit random relative to these other numbers, but one of the things that's going to happen with any kind of polynomial with a sort of a squared, an x squared term as the leading term, right, is eventually it's going to start to look like a regular x squared graph, which has pretty decent jumps, right? If you think of the jump from 2 squared is 4, 3 squared is 9, right? 4 squared is 16, so you're going 4 to 9 to 16. You're making pretty big jumps in the y values, and then from there 16 to 25 to 36 to like what comes next, 36 to 49, right? You're making pretty big jumps pretty quickly. The x squared function right, increases pretty fast, gets pretty steep. So seeing a jump from 2 to 7, these are pretty small jumps. Seeing a jump here, you can see this is a +3 jump, and then this is a +5 jump. That's not totally unreasonable. That's okay. Maybe to balance this out, you can kind of see there's maybe a little bit of a pivot point here, and we're sort of going up. Let's just sort of see if we sub in x equals 3, if we can kind of match. What would we supposed to be matching? Maybe this +2. If this is kind of a center point, -1, -1. If we can get a +2 here, that would kind of tell me that we're sort of on the right track as far as getting these points and getting a pattern going. 3 squared is 9. Minus 2 times 3 is minus 6, minus 1. And then look at that, right? 9 minus 6 is 3. Minus 1 is +2. So our table here, what we're sort of having is this is kind of like a pivot point, right? And so then we're sort of -1, +2, -1, +2. Probably if we checked x is 4, we would also get +7 again, and then this sort of values would start to mirror each other, and it would sort of continue as they got bigger. I'm going to take this table, try to keep this in frame. Should have thought about this a little bit more. And I'm going to freehand a graph, because the best way to get a really nice graph going is not to use graph paper, but to do it freehand. Don't be confused by my dry delivery. That's a joke. You should, of course, use graph paper if you haven't. I just don't have anything handy at the moment. But that's okay. If we just do a little freehand, this is not necessarily supposed to be the most definitive be-all, end-all version of this graph. That's fine. So I'll do 1 tick mark for every unit, and I'm going to roughly scale them, I guess. I'm tempted to maybe try to scale these guys a little differently. I definitely want to get up. Am I going to be able to hit this 7? I might just sort of ignore the 7. I might just try to go between the 2 and the 2. We'll sort of see what fits and sort of still shows up well. 1, 2, 3, 4, right? 2, 4. And then the negatives, we didn't go back quite as far, right? -2 is here. For my y values, sorry, those just look like smudges. That's fine. The y values go down to -2. Well, honestly, let's see. So -2 is here, and then +2. That's kind of roughly to scale. 3 would be there. That kind of just looks like I'm finishing off the arrowhead, but that's fine. So let's just graph these coordinates, the ones that sort of fit here. So we'll just go from right to left, I suppose, because that's what our table is doing. So x is +3, the y is +2, so 1, 2, 3 in the x, and then up +2. So there's 3, 2. If I go x is 2 and the y is -1, so 1, 2, and then down. So that's +2 and -1. At x is +1, I'm at -2, so we kind of are identifying that as our sort of pivot point. Over 1, down 2. 1 and -2. And then my right pattern looks like we're going to start to move back up. So at 0, our y-intercept, we're hitting -1. That's here. Try to keep these coordinate labels out of the way. And then at -1, we're up at +2. Which is there. What was our last point? So this -2, +7. Honestly, that's just going to be pretty far up the chart. We could kind of eyeball it. Maybe it would kind of be up here roughly. I don't want to draw a graph through all my nice calculations. So I'll just graph these 5 points that sort of fit cleanly into this coordinate system. Again, if you've got a graph with a little bit more space, obviously you get a little bit more room to work. The key here is when you're drawing this, so try to draw it with a nice smooth curve. So don't draw just like straight lines individually like you would with like an old school connect the dots kind of thing. Obviously what we're doing is connecting the dots, but we'd like to draw them with a smooth curve as much as possible. So these functions generally will sort of move smoothly. They won't necessarily naturally have a lot of like sharp corners. The one exception to that is our absolute value function that sort of makes like a V. Anyway, so smooth curve down to here, make the turn, head back up. We don't really have a very good sense for these like crossing points. We're kind of eyeballing these x-intercepts. Those would be a little bit trickier to find, which is fine. In theory, this would be if we were sort of factoring this out, trying to solve it for the y value equals 0. Obviously we have coordinates there, but they're not falling at nice whole numbers. They might be semi-decent fraction kind of numbers, or it could be something where we end up using a quadratic formula and like not really getting a great value at all. We could be getting a more awkward value. In any event, that's the basics of it, right? So making this table of values, right? Just sort of subbing in the x's, subbing in the numbers, getting the coordinates to go with it, x's and y's, and then just plotting them, x and y points, and then we'll connect the dots. So making a graph of a function using a table of values. Ta-da.